Hey, welcome to lesson 3 in our series about logic and the CPU. Okay, and we're going to start today with some congratulations and some well dones to a few students. Okay, just because I picked out a few pieces of work that I've been particularly impressed with. Mr. Lifton did the same thing as well, so there's a couple of students from Mr. Lifton and a couple of students from me. I'm going to start with Jonan. Alright, this was an excellent computing timeline. I really liked the way he included images in his timeline, and he had lots of information about the different devices for the different decades. So really well done, Jonan. That was an excellent piece of work. Okay, I also want to say well done to Pian. This was also an excellent piece of work on the timeline. I love the graphics that you included. I love the information that you included, and it was really good. So congratulations, Pian. That was a really good piece of work. Thank you very much. Okay, now these two students are from Mr. Lifton. He wanted me to pass on his congratulations to Zoe. Alright, he really enjoyed your piece of work on the components of a computer system, Zoe, so well done. And he wanted me to pass on his congratulations for completing the extension activity about memory as well, so really well done. And he also wanted me to say well done to Holly, who also did a very nice piece of work on the components that you find inside a computer system. Okay, so congratulations, Holly, really well done. Okay, now today we're going to move on. And today we're going to talk about logic gates. Okay, so just to recap from last week. Okay, hopefully what you remember from last week is that the most important component of any computer system, okay, whether it's your iPad, whether it's your iWatch, whether it's your phone, whether it's your laptop computer, whether it's your desktop computer, the most important component of your computer, all right, is the CPU, which is known as the brain of your computer. Okay, and just like your brain, okay, it's the CPU inside a computer that orchestrates everything. Okay, it's the thing that does everything. All right, and that's really important. So what we're going to start to look at is how the CPU works and how it's built. And how it does what it does. So hopefully you're going to find this exciting, I hope. Okay, let's get a move on, shall we? Okay, so if we just carry on with our slides. Okay, so these are the CPUs. These are what we're talking about. Okay, the two big manufacturers of CPUs that I'm sure you recognize are Intel and AMD. All right, so those are the big companies that make the brains of your computer system. Actually, they really only make the brains of your computer system inside your laptops or your desktops. You may have heard of a Snapdragon processor, which is what you find inside your mobile phone. Okay, so we're going to be investigating what happens when we dive into those and how do those work. Okay, so if we just start here, what you really need to understand is actually inside there is just a really complex electrical circuit. All right, that is all a processor is. It's an electrical circuit. Okay, but it's an electrical circuit that's been wired in such a way, okay, that it's able to perform really complex calculations. Okay, now that circuit is basically made up of millions, if not billions, of tiny switches. All right, that work in combination with something called a logic gate. Okay, and we're going to learn a little bit about logic gates in this lesson. Okay, so it's a really amazing thing, and if you get some time, I do recommend you going off and finding out a little bit about more about CPUs and CPU design in your own time. Okay, so let's just move on. So our task today, we're going to find out about different types of logic gate. Okay, so logic gates are going to connect our switches together. All right, so hopefully we understand that a CPU, a central processing unit, the brain of the computer, it's basically just made up of billions of switches, tiny little switches. And we'll get to how they're made so tiny later on. Okay, and those switches are connected together into a circuit with logic gates. Okay, and so today what we're going to do is we're going to find out a little bit more about logic gates. Now we're going to find out about 6 different logic gates. Okay, so we've got the first one, which is an AND gate, which we're going to go through together, and then you're going to investigate for yourself the function of an OR gate, a NOT gate, a NAND gate, a NOR gate, and an XOR gate. Okay, so we're going to find out about these functions in today's lesson. Okay, so before we start with this, okay, I'm just going to move on and show you this.
So let's look at why we might be reaching a speed limit for microprocessors. Now, to do this, we need to understand something about how microprocessors are made and how they work. And for this, I'm going to need a volunteer. Let's have you. Yes, you'd like to come on down. If you'd like to stand just there. What's your name?
Joe.
Joe. Okay. So a microprocessor is really a big electrical circuit with hundreds of millions of tiny switches. And to understand what they're all doing, we've got a simple example. So what we're going to do here is we're going to make a milkshake. And if we succeed, this light will come on. Now, to make a milkshake, obviously we need milk. So what I'd like you to do is to close this switch by moving that lever down. Okay? Now the light hasn't come on, so obviously we don't have enough ingredients yet. So let's suppose we also have some strawberries. So would you like to close that switch? Okay, and the light comes on. So if we have milk and strawberries, we can make a strawberry milkshake. Okay, let's suppose we don't have any strawberries. Can you open that switch for me? And let's say instead we have some bananas. If you'd like to close that switch. So again, if we have milk and we have bananas, we can make banana milkshake. Okay, let's suppose we have strawberries and bananas. So if you want to close that switch again, and the light stays on, of course. So what this says is that to make a milkshake, we need milk and we need either strawberries or bananas or both. Now that kind of reasoning is called logic, and computers are very good at it.
Okay, so hopefully in the video they've explained a little bit better than I can, okay, the importance of logic gates in the design of central processing units or CPUs, the brains of our computer, okay. So I'm just going to talk to you about this table. Okay, then this table is really, really important to us when we talk about logic gates, and this is called a truth table. Okay, now the aim of a truth table is to teach us the function of a logic. Is to tell us the function of a logic gate. Okay, so I don't know if you do functions in maths. Okay, but one way to express a function is to talk about its results and its outputs. Okay, and that's what we do. When we talk about logic gates, okay, so the way we express the function of the different gates is we express it by highlighting the output from each of the different gates. Okay, so what you see on the truth table, okay, is we've got a column here and a column here. Now, most of the logic gates that you are going to investigate from today, okay, will have two inputs. Okay, so they'll have two inputs. So here's this, for example, is an AND gate. Okay, and it will have input A and input B. Okay, so we'll have two inputs. Now the third column, this one here, okay, is the output. So all of the gates that you will look at will have one output. So all of the gates that you will look at today will have one output. All right. So what we're going to do when we investigate the function of these gates is we're going to create a circuit with a couple of switches. So we're going to put a switch here and a switch here, which we're going to connect to input A and input B. Okay, and then we're going to investigate the output from what happens when we turn on and off those switches. Okay, so hopefully you can see on my table here I've got all the possible combinations. All right, if I've got two switches, these are all the possible combinations. So I could have switch A could be off and switch B could be off. I could have switch A on and I could have switch B off. I could have them the other way around, so I could have switch A off and switch B on, or I could have switch A and switch B on. Okay, so those are all the combinations. And what I'm going to do when I create my truth table is I'm going to complete that truth table by finding out what my the output from my gate is when I'm doing all of those different inputs. Okay, so I'm going to just show you how you're going to do that using a program called Logically. Okay, so you are going to investigate all of these different gates using a program called Logically, and this is the URL that you need to use. Okay, so https Logically, make sure you put / and then demo at the end, otherwise you won't get the free bit. Okay, and it looks a bit like this. This is what it looks like. Okay, and so this is Logically, and basically what it allows you to do is it allows you to create circuits. So we're going to have a go at creating a circuit. Now we talked about the fact that most of the gates that we are learning about have two inputs. So here's our AND gate, for example. As you can see, here's input A, here's input B, and this is the output. Okay, so what we're going to do is we're going to connect those two inputs to a couple of switches, which we've got here. So we've got a switch here and a switch here. Okay, which goes there and there. And then we're going to put, just so we can see the output, we're going to connect a light bulb to the output. Okay, so we're going to wire all this up, just like this. Okay, and we just connect it all together. All right, and so what we're now going to do is we're going to just see the function of our AND gate, and we're going to see the function by trying all the different possibilities of completing that logic table. Okay, so we can see that if both of our switches are off, at this point both of my switches are off, okay, then my bulb is off. Okay, so if we go back to my table for a minute, okay, so if we just go back to the table, okay, so what we've just done is we've just said when both of them are off, the output is off. Oh, sorry, I don't know why I wrote a 1 in there. That's a bit weird, isn't it? Okay, so it is off. All right, there we go. Okay, so let's go now back to our circuit. All right, and let's have another go. So let's now it says let's turn on input A and turn off B. So let's turn on A and leave B off. Okay, and what we can see is that still our bulb is off. Okay, so we'll go back to here. Okay, and then when input A was on and input B was off, it was off. Okay, so we've got off and off so far. All right, so we'll just go back and have another go. So now we'll swap those around. So we'll turn this one off and we'll turn this one on. Okay, so it is still off at the moment. Okay, so we'll go back to here and just put off in there. Okay, so we're just writing off in there. So let's go back to our browser window for the final time. Okay, so here's our browser window, and if we just now turn both switches on, so we'll just turn that one on. Okay, and now we get our bulb going on. Okay, so if we go back to our presentation, okay, and what we'll do is we'll just put in the final one, which is if input A is on and input B is on, then this will be on. Okay, so that's called a truth table, and what this does is it reflects the function of an AND gate. Okay, and we can include even the picture of the AND gate that we got from Logically, which looked just like that. There we go. That was an AND gate. If you remember, it had 2 inputs and 1 output. Okay, so that's what you are going to do, and these just match. Okay, so your task this week, okay, is to use Logically and find out more about the different logic gates that we use in the construction of a CPU, in the construction of a processor, at the brain of your computer. Okay, so you will see there that there are 6 gates that I want you to investigate. Okay, you've got an AND, an OR, a NOT, a NAND, a NOR, and an XOR. Okay, now I will just warn you that one of those gates has only got 1 input. Okay, so you will have to create a slightly different circuit for that one. Okay, now what I want you to do, just in case you're not sure what you need to do, is you will be able to download the document that you need to complete for the logic gates. Okay, you're going to use Logically to create the circuits, and then you'll complete the truth tables for each in that document, and then just make sure you upload your results to show my homework for me and your teachers to assess. Okay, now I just want to just going to finish off where I just want to speak to you to a little bit about an extension task this week's extension task. Okay, so this time I'm going to hand you over to my whiteboard. Okay, so we're just going to go across to my whiteboard. Here's my whiteboard. Okay, and hopefully you can still hear me, which I think you can. Okay, so I just want to show you something, a little bit of binary arithmetic. Okay, so if we do some binary arithmetic, if I do, let me just use the other end of the pen. If I had a working pen. If I do 0 plus 0. Okay, now this is in binary. So if I add 0 plus 0, what do I get in binary? I get 0. Okay, and I'm going to put 2 digits there, and there's a reason for that in a minute. Okay, now what I'm going to do it again, I'm doing binary arithmetic here, not normal arithmetic, I'm doing binary arithmetic. So I'm going to do 0 plus 1. Okay, so if I do 0 plus 1, that's going to give me 1. Okay, now I'm going to do it the other way around, so I'm going to do 1 plus 0, okay, which again is going to give me 1. Okay, so so far quite simple, my binary arithmetic. Now here's where it's going to get a little bit more complicated. Okay, so finally what I'm going to do is I'm going to do 1 plus 1. Okay, now I'm just going to let you think for that. You might want to pause the video for 30 seconds there and just think about what the answer to that is. Remember, this is binary arithmetic, so just pause the video. Okay, so hopefully you pause the 30 seconds. Okay, so what's the answer to 1 plus 1? Okay, well the answer to 1 plus 1 is, of course, 1, 0. Okay, so your extension task is see if you can build a circuit. Now I'm going to tell you now that this circuit is going to combine more than one logic gate. Okay, so see if you can combine one circuit and again, you just have two switches, input A and input B. Okay, but what I want is, rather than just having an individual logic gate, you're going to have multiple logic gates, and they're going to produce two outputs. So they're going to be connected to two outputs. Okay, we're going to have output A, and out B, and the combination of outputs that they're going to produce for us are going to match what we've got there. Okay, and so basically what we're going to do, what I'm asking you to do, is see if you can produce a circuit that will add together two binary digits. Okay, so it will take one binary digit, add it to another binary digit, and give us a result. Okay, and the result should look like this table here. Okay, so you need two outputs, so you have two inputs, two outputs. Okay, and it should give us that combination of outputs. Okay, so that's what I want you to try and do for your extension task. Okay, so thanks for watching. Okay, hopefully I've made it clear what you need to do this week. Good luck with your investigation about the different logic gates, and I will see you next week.